this lecture, we are going to understand why the no-load circuit, that is this particular circuit, is in parallel with the source. What is the reason that whenever we draw an equivalent circuit of transformer, this particular no-load circuit is always in parallel of the circuit or the source. What I really want to say that we never draw the no-load equivalent circuit like this. Here, this particular no-load circuit is in series, but we never draw this kind of equivalent circuit because it is not correct. The main confusion in students is why this is in parallel. So let us discuss. As we know, no-load means when we open circuit the load terminals to determine the value of the losses in transformer, and these losses are called no-load losses. These no-load losses can be further divided into two parts. One is hysteresis loss and another is eddy current loss. Now in this equivalent circuit, this X0 or the inductive part at the no-load circuit provides you the hysteresis loss, and this R0 provide you the eddy current loss component. Clear? Now if we give the hysteresis loss component or signify as PH and eddy current loss component as PE, these two expression, that means your hysteresis loss depending upon BM and F, same as your eddy current loss. Now what is BM? BM is the maximum flux density and F is your frequency of the system. Here KE and KH are two constants. One is hysteresis constant and KE is eddy current constants, and X is something of value between 1.5 to 2.5. It is a constant called Steinmetz constant, and it solely depends, the value depends upon the property of the core material. Clear? Now let's not get into this because this will be a very big discussion on only the no-load losses and its types. What is our core focus is why the equivalent circuit is in parallel. Now how much we have understood here in these two equations, that is equation 1 and equation 2, is hysteresis power and eddy current power losses expressions. Now we know that the induced EMF equation of transformer is 4.44 phi ft, where is phi is your magnetic flux, which is again equal to B into A, that means flux density into area. F is, I have already said, frequency, and T is number of turns. Okay, now from here we can replace phi as BA and the equation remains like this. Now what is our objective? Our objective is to determine the value of B in this equation so that we can equate or we can take this value to replace into these equations. So what we are getting? We are getting value of B is equal to E divided by 4.44 AFT. Here T is your number of turns, that generally remains the same. A is the area by which the flux is passing, the entire flux is passing, and E is your induced EMF. There is a very small difference between EMF and voltage if you neglect a small potential drop across the source or across any induced voltage condition, then EMF is almost as same as equal to voltage. So we can consider, or we can replace EMF with voltage. So now if we replace the value of B of equation number 3 to this one of the equation 1 or 2, we get, let us take it 2, because here it will be easier as the square term is here. PE is equal to KE. So what we are getting here, that your eddy current loss is proportional to E square. That means eddy current loss depends upon the induced EMF or the voltage quantity. When in electrical system, if anything, any loss or any quantity depends upon voltage, then it's connected in parallel with the source. In our domestic connection, what we really need to do is to maintain the same voltage, that is single phase 220 volt generally, so that we connect all our domestic appliances in parallel with the supply. Suppose this is your refrigerator, this is your fan, this is your light, all are connected between the phase and neutral, that means in parallel connection with the supply. Same is here. Whenever your loss, whether it is hysteresis loss or eddy current loss, is directly depends upon the value of the voltage, then you certainly need to connect it in parallel with the supply. If in any case it was dependent, or it was dependent on the current quantity, then it would have been connected in series. Clear? The previously I have drawn a diagram like this, that diagram, but whenever it is connected, it is depending on the voltage quantity, then certainly we have to connect it in parallel like this in the diagram, not in series. So I think the explanation is clear to you. If you have any doubt regarding this topic, then please do mention at the comment section below. Thank you.